Hey guys, it is time for more math. We're going to start this video with a math antics. I've had lots of questions on fractions and I know we have forgotten. So yesterday we had some videos over adding and subtracting fractions. Today we're going to watch our friend Rob here again with multiplying and dividing fractions, and we'll also probably jam out to a song along with it. Okay, I know lots of friends, a couple of friends that I've talked to, as soon as I showed them how to divide fractions, they're like, oh yeah. Okay, so it's easy to remember, we just kind of need a quick reminder.
You've probably noticed that we've been talking an awful lot about fractions around here lately. Well, now I'm going to tell you something you can do with fractions that's really easy. No, not juggling fractions.
Oh my.
Although that is pretty easy for me. I'm talking about something even easier than that. I'm talking about multiplying fractions. Multiplying fractions is super easy. In fact, it's easier than adding fractions, and that's why we're going to learn it first. The reason it's easier is because fractions are really just division problems, and multiplication and division get along much better than addition and division. Now, since fractions are division, that means if I have the problem 1/4 times 2/3, it's the same as the problem 1 divided by 4 times 2 divided by 3. That means I have both multiplication and division in the same problem. And because they get along so well, that means I can just rearrange our problem to look like this. Now it looks like two multiplication problems that are being divided, and it looks just like a fraction. In fact, if we go ahead and do the multiplications, 1 times 2 equals 2, and 4 times 3 equals 12, then we do have a fraction, and it's the answer to our problem. So what does all this mean? Well, it means that to multiply fractions, all you have to do is multiply the top numbers, and then multiply the bottom numbers, and ta-da! There's your answer. As always, let's see an example or two. Let's try this problem, 2/3 times 4/5. Now we could rewrite the problem like we just saw, but that's not necessary as long as we remember the procedure. First, we know our answer is going to be a fraction, so let's go ahead and write a new fraction line for it. Next, we multiply the top numbers. 2 times 4 equals 8, so 8's the top number of our answer. And last, we multiply the bottom numbers. 3 times 5 equals 15, so 15 is the bottom number of our answer. There we have it. 2 over 3 times 4 over 5 equals 8 over 15. See how easy that was? And fun, too. Even funner than video games. Okay, time for another example. Let's try 6 over 11 times 7 over 8. From our multiplication table, we know that 6 times 7 equals 42. So 42 is the top number of our answer. And on the bottom, we have 11 times 8, which is 88. So 6 over 11 times 7 over 8 equals 42 over 88. Oh, now some of you might see that this answer could be simplified, but we'll save simplifying fractions for another video. All right, let's see one last example. Here it is. 1/2 times 4 over 3 times 3 over 5. Wait a minute, this has 3 fractions multiplied together, and the middle one looks like an improper fraction because its top number is bigger than its bottom number. Does our procedure work for this problem too? Yep, all we have to do is multiply all the top numbers together, and then multiply all the bottom numbers together, and we'll have our answer. And this will work no matter how many fractions we have to multiply. So on the top, we have 1 times 4 is 4, and 4 times 3 is 12. And on the bottom, 2 times 3 is 6, and 6 times 5 is 30. That means our answer is 12 over 30. So there you have it. Multiplying fractions is easy because fractions are just another way of writing division problems. But remember, there's another way to think about fractions. We can also use fractions to represent parts of things, like half a pizza, for instance. But does it make sense to multiply half a pizza by another half? Actually, it does. If you're thinking of fractions as parts of something, then multiplying fractions is really like taking part of another part. For example, here's half a pizza. Now you can see that if I take 1/2 of that half, then I get 1/4 of a pizza. And if we do the multiplication 1/2 times 1/2, you see that we do get 1/4. So that's why you can think of multiplying fractions as taking part of another part. In fact, sometimes, especially in word or story problems, you'll see multiplying fractions written using the word of instead of times. They may ask, what's 3/4 of 2/3? And now you know they just mean, what's 3/4 times 2/3? So, whether you think of fractions as parts of something or as division problems, the procedure for doing the multiplication is exactly the same. Let's do a quick review of what we've learned. Multiplying fractions is even easier than adding fractions. It's easy because order of operations says that we can do the multiplication before the division. The procedure for multiplying fractions is to multiply the top numbers to get the answer's top number, and multiply the bottom numbers to get the answer's bottom number. If you think of fractions as parts of something, then multiplying a fraction by another fraction is the same as taking a part of a part. And sometimes, especially in word problems, you might see the word of instead of the word times. Even though multiplying fractions is so easy, it's a good idea to practice.
We are going to practice, Rob. Thank you. Dividing fractions. Remember that word reciprocal?
Hi, and welcome to Math Antics. This video is all about dividing fractions. But in order to understand how dividing fractions works, we first need to learn about something called reciprocals. A reciprocal is just a fancy math term for what you get when you switch the top and bottom numbers of a fraction. For example, if you have the fraction 1/2 and then switch the top and bottom numbers, you'll end up with 2/1. 2/1 is the reciprocal of 1/2, and 1/2 is the reciprocal of 2/1. And an interesting thing about reciprocals is multiplying a fraction by its own reciprocal will always give you 1. That's because you'll have the same multiplication problem on the top and bottom, so you'll end up with a whole fraction, which is always 1. Okay, that's nice. But what do reciprocals have to do with dividing fractions? Well, reciprocals let us do a really cool trick that makes dividing fractions easy. Whenever you have to divide something by a fraction, you can just multiply it by the reciprocal of that fraction instead, and you'll get the correct answer. And that's great news because multiplying fractions is so simple. This trick of multiplying by the reciprocal works because fractions are really just mini division problems. So when you multiply something by 1/2, it's the same as dividing by 2, since 2 is below the fraction's division line. And dividing by 2 is the same as dividing by 2/1, because you can turn any number into a fraction by just writing a 1 as the bottom number, right? But look, reciprocals. That's why multiplying by 1/2 is the same as dividing by 2/1. And it's true the other way around, too. So really, it's kind of like you never have to divide fractions. You can just rewrite your division problems so that you're multiplying by the reciprocal instead. Then when you multiply, you'll get the answer for the original division problem. As always, let's see a couple examples of how this works so you'll really understand. Let's try this problem. 3/4 divided by 2/7. Okay, so the first thing we want to do is rewrite our problem. Instead of dividing by 2/7, we can multiply by the reciprocal instead. The reciprocal of 2/7 is 7/2. So our problem becomes 3/4 times 7/2. Oh, I should mention a mistake that a lot of students make when they first learn to divide fractions. Sometimes students take the reciprocal of the first fraction, the one that's being divided, or even the reciprocal of both fractions. But you only want to take the reciprocal of the second fraction, the one you're dividing by. Okay, now that our problem has been changed to multiplication, it's easy. Just multiply the tops, 3 times 7 equals 21, and multiply the bottoms, 4 times 2 equals 8. And we have the answer to our fraction division problem. So 3/4 divided by 2/7 is 21/8. So that's pretty easy, but let's try one more example. Let's try 15/16 divided by 9/22. Again, the first thing we want to do is rewrite our problem. We'll change the divided by 9/22 into times 22/9. Now all we have to do is multiply. But since these numbers are kind of big, I'm going to use my calculator to help. Let's see here. So we have, all right. On the top, we have 15 times 22 equals 330. And on the bottom, we have 16 times 9 equals 144. So the answer to our division problem is 330 over 144. Of course, that could be simplified for your final answer on a test, but we cover simplifying fractions in another video. All right, that's how you divide fractions. You just multiply by the reciprocal and you have your answer. But there's one more thing I want to show you. You already know that the line between the top and bottom number of a fraction is just another form of the division symbol. Well, that means you'll sometimes see fraction division problems written like this. This shows the top fraction, 2 over 3, being divided by the bottom fraction, 4 over 5. It's really just that we have a fraction made up from other fractions. The top number is a fraction, and the bottom number is a fraction. It just looks a little confusing because we have all these fraction lines here. But we can make it look a lot better. Let's rewrite this as a multiplication problem by taking the reciprocal of the bottom number, the fraction that we're dividing by, and multiplying it by the fraction on top. There, that looks easier to do, and it's really the same problem. We just need to multiply to get the answer. So 2 times 5 equals 10, and 3 times 4 equals 12. Okay, so there you have it. What sounded really hard turns out to be as
Okay, ladies and gentlemen.
easy as flipping fractions upside down. If you can multiply fractions, then you can divide fractions too. Don't.
Okay. Our last stop with fractions. When you turn in an answer, and I saw some answers like this today, for example, 4/12. Is that an answer you should submit on your test? No, you need to simplify. Always simplify.
In a previous video, we learned all about factoring whole numbers. And now we're going to learn how factoring can help us when working with fractions. We're going to learn how to simplify fractions. Simplifying a fraction means rewriting the fraction using the smallest top and bottom numbers we can without changing the value of the fraction. To help us understand what simplifying a fraction really means, let's take a look at the simplest fraction I can think of, 1 over 2. Now, this is already as simple as it can possibly be, so let's go the other way and complicate it by dividing our rectangle here up into more parts. The amount of our rectangle that's shaded is still the same, but now the numbers for our fraction are 3 over 6. The numbers are bigger because our rectangle is now divided into more parts. The fraction we have now, 3 over 6, is equivalent to our original fraction, 1 over 2. That means they have the same value. They represent the same amount. So what if someone gives you the fraction 3 over 6, like 3/6 of a candy bar? Well, we know from our picture that that means they're really giving you 1/2. But how can we show that using math and not pictures? Well, that's where factoring comes in. Let's take our complicated fraction, 3 over 6, and factor both the top and bottom numbers. Now, the bottom number 6 can be factored into 2 times 3. The top number, 3, is a prime number. Its only factors are 1 and itself. So we can write that as 1 times 3. There, we've rewritten our fraction using factoring, and now it kind of looks like two fractions being multiplied together. 1 over 2 times 3 over 3. Of course, 3 over 3 is what I like to call a whole fraction, since its value is equal to 1. Now here's the interesting part. Since 3 over 3 equals 1, and multiplying by 1 has no effect on a number, we can just get rid of that 3 over 3. Basically, the 3 on the top and the 3 on the bottom cancel each other out. And once they're gone, we're left with the fraction 1 over 2. So that means that the fraction 3 over 6 simplifies to 1 over 2. Another way of thinking about it is that we're trying to find any whole fractions that are hiding in the fraction we're trying to simplify. And if we find any, we can just get rid of them, and the fraction we're left with is simpler than the one we started with. Now that we know the basics, let's learn the procedure for simplifying fractions. First, replace the top and bottom numbers of the fraction with their prime factors. Next, look to see if any of the factors are the same on the top and bottom. If they are, then we call them common factors because there's something that both the top and bottom have in common. If you find a pair of common factors, you can cancel them out. Just draw a line through them, like this. And last, once all the common factors have been canceled, you need to remultiply any factors that are left over on the top or bottom. This makes sure that you end up with only one number on the top and bottom of your simplified fraction. Oh, and there's one important thing to remember. If you're ever able to cancel out all of the factors on the top or bottom of a fraction, don't be tempted to write in a 0, put a 1 in there instead. The reason you can write in a 1 is because 1 is always a factor of any number. It's just we usually don't write it in. For instance, if you're going to factor the number 15, you just say that it's 5 times 3. But you could also say that it's 5 times 3 times 1. In fact, you could even say it's 5 times 3 times 1.
Alright, we're
See
gonna
why
fast
there's
forward
always
to
a
a
1
couple of
left over
this.
when you're canceling common. Any factors that are the same on the top and bottom. We call those. We know that 15 factors into 5 times 3. And 5 is a prime number. That means its only factors are 1 and itself. But 1 is always a factor, so we don't need to write that down. Step 2 is to look for common factors and cancel them. And we can see that there's a 5 on the top and there's a 5 on the bottom. They're not directly over each other, but that doesn't matter. They still form a common factor pair, and so we can cancel them out like this. Step 3 is to reorganize our answer. Now we don't have any factors that need to be recombined by multiplying. We just have a 3 on the bottom, and we don't have any factors left over on top. But you'll remember that there's always a factor of 1. So 5 over 15 simplifies to 1/3.
Okay, ladies and gentlemen, we're going to stop there. We are going to go ahead and do some practice, and then hopefully we'll get to our songs. If you go to courses and go to math, oh man, is our internet still down?
Yeah.
Oh jeez. Okay, we might do our song now in hopes that it gets going. Okay, song it is. Multiplying fractions, and then you remember, if you have to multiply a fraction by a whole number, what can you put that whole number over? Put a whole number over 1. Very nice. Then you can multiply. Can you what? The quiz? No. You guys always want to do the quiz.
I want to do a quiz on multiplying.
Uh-oh. Is there our internet and Schoology?
Oh yeah, it's quiz now. Yeah.
Okay, here it goes.
Three of us found treasure on a scuba trip, so we pulled our treasure up onto the ship. Since we were so blessed by this rarity, we decided to give half of it to charity. We took the rest, split it up 3 ways. 1/3 of the rest was still a huge payday. 1/3 from me, 1/2 for charity. So what's my share? Let's multiply and see.
When we need to multiply 2 fractions, this is our reaction. Multiply the numerators, then multiply the denominators.
My friend and I were digging for dinosaur bones. We decided to search in a rectangular zone. We split it equally between the 2 of us. The first day I found a bone from a brontosaurus. I found a few more by the end of day 2, when 3/8 of my half had been searched through. Of my half, I had explored 3/8. How much of the entire space did I excavate?
When we need to multiply 2 fractions, this is our reaction. Multiply the numerators, then multiply the denominators. When we need to multiply 2 fractions, this is our reaction. Multiply the numerators, then multiply the denominators.
full of videos and songs today, guys. Just part of our reviewing.
There's so much for math. Okay, more?
Let's do just one dividing one. Divide a whole number
Yeah, I need
by
the
a
whole
fraction or divide a fraction
number.
by a whole number.
The whole number looks cool.
That one looks cool. That's what you guys based it on.
No.
Either way, we still have to find that reciprocal.
And build two walls.
Oh, we did this.
Each wall one block with 1/4 of them all. 2 divided by 1/4 equals 8. 8 blocks to build the wall at my castle gate. To divide a whole number by a fraction, we start by dividing the whole number into fractional parts. Look up the number of fractional parts present, and that will be the quote.
I'm gonna stop this one. I was hoping they would show you the reciprocal. Let's try the other one.
Yeah.
Four friends sat down at a pizzeria and shared 1/2 of a pizza. 1/2 divided by 4 is 1/8. That's the amount of the pizza each of them ate. Draw one whole pizza and then the fraction. Divide it by the whole number and find the quotient. Draw one whole pizza and then the fraction. Divide it by the whole number and find the quotient.
We're gonna stop this one too. I was hoping they were gonna show you the reciprocal, but they weren't showing you using the reciprocal. So we're gonna stop there. Okay, but you guys know we don't actually divide fractions. We are going to flip that second fraction, find its reciprocal, and then multiply across. All right, ladies and gentlemen, I cannot show you the problems on the Promethea board because Schoology is down for right now. But my class and Mrs. Long's class, I did print. Put on my right light for me. You have printed for you the problems that we're going to do together today. And my e-learners, it will be on Schoology when it is working, and so will your video when you're watching this. Obviously, Schoology is working. All right, we're looking at computation, algebra, and functions. It's going to look like this at the top. Put your name at the top. Number 1.